Okay, good morning, class. So today we're looking at the grade 10 November paper 2 of last year. Is it date? No date. Only November 2020. Alright, so at this point we look at all the questions up until question 6. So now we're going to look at question 7. Alright. So here we are told that the graph of f of x equal to cos x for x in element of 0 to 360. So you go from 0 to 360. Which is the cos graph. As you can see, it starts by the maximum, minimum, back up, 360. On the set of axes given in your answer book, sketch the graph of g of x equal to cos, sorry, g of x is equal to 2 sine x minus 1. Alright, so as I showed you, can use a calculator. If you know all the parameters of this graph, it will be easy to draw the graph as well. Okay? So I'm going to draw it first. So 0, 0, minus 1. Then it's 90 and 2, so it will be 90 and 1. Then 180 and 0. 180 and minus 1, of course. This is 270 and minus 2, 270 and minus 3. And then, of course, this point here. People, that's an end point, so I write this coordinate in. And this here as well, it's a turning point. So I write that in as well. Sorry? So what I do is I connected the dots, okay? Now, many of you don't study the parameters of the graph. So you could have used the table as well. Okay. So let's go with the calculator. We say mode table. So f of x is equal to 2 sine x. Sorry, my. Third is so. Because of the hay fever of yesterday, it was heavy. Alright, so we're going to start at 0 and we're going to end at 360. And we're going to go with steps of 90. With a 10, we go steps of 45 degrees. Not so. So steps of 90. So it goes 0 and minus 1, 90 and 1, 180 and minus 1. 270 and minus 3 and 360 and minus 1. Okay, you guys understand? Yes. Right, it's because it's more than one graph on the system of axes. I named that G. That is, of course, f of x. Alright, let's look at the next question. The next question says write down the period of f. People, period is time taken to complete one full cycle. So to start, from start to end, the period on the f graph is 360. What's the period on the g graph? Also 360. See, neutral, max, min, back to neutral. 360. And then after this, what's going to happen? Another cycle is going to take place, and another one, and another. This goes all the way to infinity, and it goes all the way to negative infinity. You guys understand? What is the amplitude of G? Now the amplitude is from the neutral to the maximum. Can you see how many units is this? 2. So what is the amplitude of G? 2. Sorry? Yeah. So it's going to be 2. You guys understand? Dobre? Minute is kaya ka na. Alright, next one. Yes? Did you watch the lessons? Huh? Did you watch the lessons? Huh? Okay. So what is amplitude? The lesson I've explained what amplitude is. What? The amplitude is from the neutral point to the maximum. Can you see here? Now if this is -1 and that is +1, how many units is that? From the middle to the maximum, how much is this? 2 Anna? You see it's 2. So the amplitude is 2. So if you look at this graph here, the F graph, where's the neutral? Here. Can you see that? That's the middle. Can you see? The middle to the maximum is how much? 1 unit. So the amplitude there is 1. You understand? Even if this graph had to go this way around, the G graph with the F graph, you see neutral, maximum. What is that? 1. So the amplitude is 1. Irrespective if that graph is, sorry, it goes here. Even if the equation of this graph is y is equal to negative cos x. Even though it's negative, the amplitude is always a positive reading there. Yes. Okay? So it's 1. Okay, let's look at the next question. Write down the range of m if m of x is equal to -3 f of x plus 1. People, what is the range? What is the range first? All possible y values. What is the range of f of x? Goes on negative? No, just f of x. F. This is the graph of f. Does this graph exist at negative infinity? No. Where does it start existing at? -1 till 1. Can you see here? This graph I'm talking about. For those of you calling out the wrong answers. That graph does not exist at negative infinity. It starts existing at -1 till 1. So the range of that graph is now for f, that y is greater than equal to -1, less than equal to 1. Okay, but now what effect does this -3 have in front of this graph? The amplitude will shift now to 3. And what effect does that negative have? It flips the graph. Okay, so if I must draw this graph, -3 cos x, 3 cos x graph, then, as we say, the graph is flipped, and the amplitude is increased to 3. Okay, so that's of course it goes to 3. This is a clear indication you guys didn't do the work I gave it to you. I'm actually scared now to mark your papers. You guys wrote this morning. They're telling you go study the stuff. I'm not telling you to go waste your time. This is your future, people. Okay? Especially for those of you who want to go into a field that requires maths or a course that you need maths for. Okay? Don't waste your time. TikTok and what. No? You're wasting your time, people. Become serious about your work. Your education is in your own hands. Don't mess it up. The more we do for you guys, the less you guys do. Well, what's the range of this graph here? Goes from -3 to 3. So what's the range here? Y is greater than equal to -3, but less than equal to 3. Why am I including 3? Because the graph exists at 3 and -3. You see that? Now, what effect does +1 have on the graph? Shifts 1 unit up. So if I look at the range of that graph, this graph will shift 1 unit up, So the negative 3 becomes negative 2. 3 becomes 4. And of course, can you see that? So what's the range of this graph? Y is greater than or equal to negative 2, but less than or equal to 4. Okay. But some of you can do this in your head as well, no? And at this point, if you know the parameters of these graphs, you can just do a rough sketch and then you should be able to get it done. Okay. So here the answer here is y is greater than or equal to minus 2, or less than or equal to 4. Then they want to know in 7.5 for which values of x is g increasing. G is increasing. So if we look at this graph, just take this unnecessary stuff off. So let's look at the G graph. The G graph is the one that's initially drawn. So what do you notice here? Is this part of the graph increasing or decreasing? Decreasing. It's decreasing from 1 to 180. And then it's increasing. Can you see that? But they want to know where the graph is actually increasing. So it's increasing from 180 to 360. So x is greater than 180. What they said? Okay. Yes? Yep, absolutely correct. My mistake. I wouldn't have budget full marks, you see. I wasn't studying. G is increasing. So about G, is this increasing or decreasing? It's increasing from there to there. And then decreases. And then increasing again. This is two different parts. So what do I say? X is greater than 0. But they said 90. Or x is greater than 270. Okay, yes, Michael.
When we draw the graph,
Yes?
do we have to put the coordinates?
Rather be safe and write it in. Okay? When I do the allocation of marks here, I give a mark for coordinates. Okay? But not on every exam. From other people do they allocate a mark. Okay? I allocate a mark. So if you leave it out, you're going to lose a mark. But like I say, there's teachers that doesn't allocate a mark. Okay? I always want you to write it. Okay. Anything else? Last question, people. For which values of x is... Let's get this Mickey Mouse open. They want to know for which values of x is g times g of x times x less than or equal to 0, or x times g of x less than or equal to 0. People, what does less than 0 mean? It is negative. Not so. Under what condition, when I multiply two numbers, is the number negative? Positive and a negative. Or a negative and a positive. Not so. That's the only way I'm going to get a negative. If it's a negative times a positive, or positive times a negative. Not so. So, if you're looking at g of x, what is g of x? This graph here, not so. So g of x is this graph in blue. Okay? What is x? The bar, the x bar. Can you see it? But what do we know about this x? This x is always positive or negative?
Positive.
Positive. The x is always positive. If I had to draw the graph on this side, the x would have been negative. You guys understand? So in other words, the graph must be positive and this bar must be positive, but negative, or vice versa. But what did we say? This bar is always positive. The x is positive, so we're not going to even consider that one. Okay, so it's only where, so the whole bar is positive, it's only where the graph is negative that we are interested in, or equal to 0. So, when is something negative? If it's below this line here. You see that y is equal to 0?
Yes.
That's negative and that's positive. So we're going to look where the graph is negative. So is the graph negative or positive here? Graph is negatively. Okay? Here the graph is positive. And then the graph is again negative. Okay. So we are actually interested in this point here as well. Okay. So how do I get that point? That is what point is this? X-intercept. Not so. How do you calculate x-intercept? Let y equal to 0. And what's the equation of this graph? What's the equation of g of x? Huh? 2 cos x minus 1. So if I say this equal to 0, x-intercept, let y equal to 0. So 0 is equal to 2 cos x minus 1. Make x cos x the subject of the formula. So 2 cos x equal to 1 divided by 2. So cos of x equal to half. But take r cos over half. X is going to give you an answer of 60 degrees. There's also a special angle. So, we go back here. This is actually on this side. Supposed to have been on this side. Can you see that?
Yes.
No, this is sine here. What's the equation of g of x, people, man? Hello? The 2 sine x. So why do you tell me? I'm doing the wrong calculation. So it'll be 2 sine x. So x-intercept, let y equal to 0. So 0 is equal to 2 sine x minus 1. You make sine x the subject of the formula, so sine x is equal to half. My reference is going to give you 30 degrees. Okay, which now makes sense. Okay, then this is going to be 30 here. Can you see that?
Yes.
We are also interested in that point there. Okay? So as you can see, that distance and that distance is about the same. 180 minus 30. So it'll be 150. Alright, so I can now, there's enough information to actually draw that inequality. So I say therefore, x is greater than 0 or less than 30 degrees. Or x is greater than 150 but less than 360. Now coming back here, it says equal as well. As you can see here, at 0, it is less than 0 on your y. So it's equal to 0 there. At 30, it's equal to 0. So equal as well. At 150 is equal to 0, yes. At 360, it is less than. So that is the solution. Just check there what I've written in the memo. Huh? Same. Okay. It's definitely not worth 2 marks, okay? But the reason why I gave only 2 marks here was because I know that many of those students in that year couldn't have answered it. They battled with it when we did it in class. So I just put it in. So and if you got it wrong, they didn't lose so many marks, okay? And many of them just left it out because they know they're going to miss this good question. Okay, so let's carry on. Now we look at question 8. Question 8, we are told a rectangular pyramid has a height of 8 centimeters. Are we given the pyramid now? A rectangular pyramid is given a height of 8 centimeters. Did I read rectangular? Triangular. A triangular pyramid, base pyramid should have been. Okay, as a height. So the height is going to be from the apex to the midpoint here. That's going to be a height, perpendicular. No? That's going to be 8 centimeters there. And on the equilateral triangle base, with sides of 5 centimeters each. Okay. The question says calculate the area of the base of the triangle correct to 3 decimal places. So if you're looking at the base is an equilateral triangle, not so measuring 5 centimeters a piece. Okay. So to calculate the area, it's going to be half base times perpendicular height. Not so. So the perpendicular height here we need to calculate. However, the base is 5. So it's half times 5 times the perpendicular height. So if I extract this triangle here, this right angle triangle to apply Pythagoras with, then this length is going to be 2,5. So let's call this x for now. So x squared is equal to 5 squared minus 2.5 squared. There's 25 minus 6.25. 25 minus 6.25 gives you 18.75, the square root of that. So it'll be 5 root 3 over 2. So what agree with that? 5 root 3 over 2. Okay, I'm still getting them and go. So therefore the area of this base is going to be a half times 5 root 3 over 2 times 5. Gives you 25 root 3 over 4, which is 10.83. Is that correct?
Yes, sir.
10.825. Is that correct? Where's the memo? Okay. So let's look at the next question. 8.1.2 says determine the volume of the pyramid. How do you calculate the volume of a pyramid? Of this pyramid? Huh? You guys wrote on this section today. Huh? A third, yes, a third. So the area, the volume is going to be a third area of base times height. A third area of base times the perpendicular height to the depth of this object. Okay, so it will be third. What type of base is this? Triangular base. So the area of the triangle we just worked in the previous question. Not so. Lisa, Kanye, why are you closing your eyes? Don't you want to see? Oh, you want to see. Now the perpendicular height, which is 8. So it's going to be a third times the area of the base, which is the answer, last answer calculated, times the perpendicular height, which is 8. We give it 28,868. Is that correct?
Yes.
Centimeters cubed. Okay. Next question. If the height of the pyramid is double, Write down the ratio of the new volume to the original volume. How many parts is expanded here? Or how many lengths, or how many dimensions are affected here? Here it says the height of the pyramid is double. So only one dimension is double. Not so. Which means to say that the volume of the original to the volume of the of the new area. The original volume is a third area of base times height. And then the volume of the new one is going to be third. The area of the base remains the area of the base. Not so. Times the height, which is doubled. So it's 2h. Can you see that, people? So what do is, I divide it by a third, ah. So that cancels, so it's 1. That cancels, and the h cancels. So it's 2 is to 1. If you had written Vn first, so I wrote it the other way around, so 1 is to 2. Okay? If all three dimensions are changed, then it's of course going to be k cubed. Not so. And because it's doubled, so it's going to be 8. 1 is to 8. Okay? Next question. Here we are told that in the diagram below shows a solid made up of a hemisphere. What is a hemisphere? Half a sphere, yes. A hemisphere placed on top of a right circular cone with a radius r and the slanted height s. The perpendicular height of the cone is 6.5, the perpendicular height. So this here is going to be 6.5. Okay? And the volume of the cone is going to be 83,38 centimeters cubed. Okay, so the diagram below shows a solid made up of a hemisphere placed on top of a right circular cone. So this volume is only the volume of the sphere. You all agree with that? Okay. The perpendicular height of the cone is right, and the volume of the right. First question. Show that the radius of the cone is equal to 3.5 centimeters. So that is the volume. That is the radius. Can I use that in my calculation? No. Can't use that in the calculation. So we know that the volume of a cone is what? A third area of base times perpendicular height. Not so? The base, what type of base is this? Circular base. So area of a cone is equal to a third pi squared times height. So what is the area? Not the area, the volume. So what is the volume of this cone? 83.38 is equal to a third pi times radius squared is what I'm calculating times the height of this cone is 6.5. To get r on its own, r squared I divided by a third pi times 6.5. So it's a third pi times 6.5. That cancels. Gives you r squared equal 3.38 over a third pi times 6.5. 12,25. And then what do I do from there? Square root 3,5, as you can see. 3,5 centimeters. Now say for instance you didn't manage to get 3.5 out. Then in your next calculation, if needed, we use 3.5. We don't use the answer that you guys have calculated. You guys understand? Alright. Let's carry on. Then in 8.2.2 the question says, show that the slanted height of the cone is 7.38. So if you look at this cone here, then of course you can apply Pythagoras theorem. Not so, but this is going to be 3.5 of course. You all agree with that?
Yes.
So, that's 3.5 there, 6.5. So the slanted height is squared is equal to 3.5 squared plus 6.5 squared. Do I need a reason here? Huh? No. I need a reason in Euclidean geometry. Unless a question states with reason, then you give a reason. Okay. It's 3.5 squared plus 6.5 squared. The square root thereof is going to give us the square root of 218 over 2, which is also equal to 7.38 centimeters, which confirms that answer there. Okay? The question paper and memo can be found in the description box below.
So why is it grade 11 in 2016?
Sorry?
Why is it grade 11 in 2016?
It's grade 11.
No, is where it's out of
How is your paper?
It's the written.
I copied it. I was cutting the grade 11 paper as well. Okay, which paper is this? Last year's paper? 2022 in our school. Thank you, Michael. Okay. Let's look at the next question. Calculate to two decimal places the surface area of the solid. Calculate to two decimal places the surface area of the solid. Okay. So now the solid, remember, the slanted height is 7.38. Okay. The radius of course is 3.5. Now to calculate the surface area, total surface area is going to be, how do we normally work out the surface area of a cone? Area of base, which is pi r squared plus pi r s. Now you see this pi r squared here, it's not taken into account as a surface area. Why? Because the hemisphere is placed on top of that thing. Okay? So that's why I'm going to leave pi r squared out. Plus, how do we calculate a sphere? 4 pi r squared, not so? But divided by 2, 2 pi r squared. So that's a hemisphere. Plus, now if you got the hemisphere, then we calculate the dome, that part, plus the area of this circle here as a base, which is pi r squared. However, that is placed on top of here. So am I going to add that in as well? No. That one is also out. Okay. So let's go. We do the calculation. It's going to be pi. The radius is 3.5 times slanted height, which is 7.38 plus 2 pi, and my radius is 3.5 squared. So it's going to be pi times 3.5 times 7.38 plus 2 pi times 3.5 squared gives us 158,12. Is that correct? Centimeters. Okay. Any issues there? No? Look at question 9. Complete the following statement. So this is now coming to the midpoint here. So the line through the midpoint of two sides of the triangle is parallel to the parallel and will be parallel to the. So basically what they have is a line through the midpoint. So that is equal. So we said here the line through the midpoint of two-sided. Suppose there be two sides. In a triangle is parallel to the third side. The length of the third side. No, that doesn't make sense. No? And half the length of the third side. So it's half. Okay? So mustn't I say this? The line through the midpoint of two sides in a triangle is parallel to and half. Oh, there they are already saying. Sorry, man. Parallel, they are saying, and half the length of the third. Sorry, man. Okay. Definitely your English is better than mine. Right, let's with that in mind. So of course the midpoint theorem is going to come into play here. Right. It's a bit bigger. So here we are told that in the diagram below, a triangle JHG is drawn with GP equal to PH and GR equal to RJ. People, what should have happened here was this supposed to have, this is two strokes.
Yes.
And that is two strokes. No? One stroke and one stroke. It's not all one stroke. Okay. Then we are told that PR is 14, G is 40, and GRP is 65. The question says, determine the reason, the size, determine the reason, the value of X and Y. So here's X. Okay. So firstly, X and that angle here is the same provided these lines are parallel. Not so, but we know that lines are parallel. So we say that PR is parallel to HJ. Why? Because of the midpoint theorem. Alright, so it's parallel. Now what? Now, this angle is equal to X. So GPR is equal to 180 minus 65 minus 40. Why? Sum of triangles. And it's triangle GPR, which is 75. Not so? So therefore, X is equal to 75. Why? Corresponding angles are equal with PR being parallel to H. Okay. So this is 75. And then Y, we said that this will be double that length. Not so. And then Y is equal to 2 times 14, which is 28. Why? Because of the midpoint here. Alright, any confusion there? Alright, let's carry on. So here we are told, let's make this a bit bigger. In triangle ABC. This length is equal to that length here. So A is equal to EB and EF is parallel to BC. What is this? Don't look like it's parallel, right?
Looks like equal.
It looks like it's equal, parallel. In triangle ACD, we are told that FG is parallel to C. The question says prove that AG is equal to GD. AG. Oh, this here. Not so. This will be equal if AF is equal to FG. Sorry, FC. Converse of the midpoint here. But we know that FC we know that AF is equal to FC. Why? The converse of the midpoint here. Not so. So those lengths are equal. And then in turn, those lengths are equal. So therefore, AG is equal to GD. Why? Again, converse of midpoint. Okay, it is so easy. Let's look at the next question. Question 10. Complete the following statement. The diagonal of the rhombus intersect at 90 degrees. Okay, so it's equal to 90 degrees there. Here we are told that, this is a bit bigger. Here we are told that K, L, M, N is a rhombus. So if the 6 properties comes to mind, is it 5? 5 properties comes to mind. What are the 5? All sides are equal. Then 2 pairs of opposite sides are parallel. That's also indicated here on the diagram already. Diagonals bisect at 90. Diagonals bisect the vertex angle. So those angles are equal here. One more.
Each side is perpendicular. Parallel.
Opposite angles are
Parallel.
equal. One more. So it's 6. What are you saying, Lisa Kanya? Okay. But not equally. The angles bisect each other. Not equally. There are only 2 shapes where the angles cut each other equally. Square and a rectangle. Those are the 2 where the diagonals bisect each other equally. Which means to say that the angles are also equal by definition. Okay, by default. Alright, so first question. We are asked to calculate with reason the size of L1. Now there's L1. So we already said O1. We said that O1 is equal to 90 degrees. Why? Diagonals perpendicular in rhombus. Okay. And now L1 is equal to 180 minus 90 minus 34. And the reason is sum of triangles. 180 minus 90 is 90 minus 34 is 56. So check if that is correct. Okay, let's look at number 2. Number 2 says calculate with reason the size of size of K in M. K in. So we know it's one of two things I can do. Nah? You can either say that is 56 and then opposite angles are equal. Nah? Or I can say that and that is equal. And then go interior angles. Not so. Either way. Okay? So I want you to work out K in M. It's the double angle. So I'm going to go with the first one. So firstly, L2 is equal to 56. Why? Diagonals bisect the vertex angle in a rhombus. Okay, so that's 56. And then angle L, which is KLM, is equal to K in M, which is equal to 56 plus 56, 112. Is it the 112? And the reason is opposite angles are equal in rhombus. Okay? 2 marks in. I think you should have gotten a bit more there. Say, I would have given you. Should I given you? Did I say this paper? Huh? No, okay. I would have given you 4 for it. Or is there an easier way of doing it? No, okay. Right, so here we are given PQRS to be a parallelogram. People, if this is a parallelogram, what do we know? We know 4 things. We know 4 things. 2 pairs of opposite sides are equal and parallel. Okay? Huh? Opposite angles are equal. One more. The angles bisect each other. Not at 90. There are 3 shapes where that is the case. The first one, rhombus, kite, square. That is the 3 quads where the angles cut each other at 90 degrees. Okay, so the question says prove that triangle PQR is congruent to RS P. RS. Okay. So let's see how much we got left for this paper. Okay, so the balance of this we'll do the next lesson. People, enjoy the rest of your day. Good afternoon, class.